Hi there and welcome to another math lesson. This time we are talking about multiplying fractions. Okay, and I just have to repeat what I've been saying in every single video regarding fractions so far, is that a fraction consists of a numerator and a denominator. Let me just short that. A denominator, where the denominator tells me how many pieces, okay, and how many pieces was divided, okay, and the numerator tells me how many of those pieces that I'm talking about, how many is counted. Okay, so, and we used the example of taking a cake, and let's say we divide a cake into 5 pieces. Let's start with 5 pieces. How do we divide with 5 again? Okay, 5, look, maybe something like this. Okay, 5 equal shares. They should be equal in size. Okay, that means my denominator will be 5. And if I look at 2 of the 5, then it would be 2 pieces of something that was divided into 5. So we can say it's not, this would be smaller than 1, and the reason why it's smaller than 1 is because 1 represents the whole thing. We divided the whole thing into 5 pieces, and we're only looking at 2 of those pieces, so that's less than 1. Okay, now what would happen if I multiply a fraction? How do I actually multiply a fraction? Well, just to remind you, if I were to multiply this with 2, then all that it means is that I have double what I used to have. If I multiply something with 2, I'm just doubling it. So instead of having 2 of the fifths, I now have 4 of the fifths. Okay, so when I multiply, I actually just multiply the numerator, 2 times 2. Okay, because it actually just means I multiply, the numerator tells me how many I have. So when I multiply the numerator. When I multiply, I don't have more or smaller slices. Okay, so I don't divide everything with 2. No, I'm multiplying the numerator, and therefore, so for example, if I had 7 over, let's say, 20, and I multiply this with 4, I've got 7 over 20 means something has been divided into 20 pieces, and I took 7 of those pieces, and I'm considering that. Now I multiplied with 4. It means I've got 7 over 20 plus 7 over 20 plus 7 over 20 plus 7 over 20. Remember, multiply means how many times were they added. So I've added it 7 times, and you remember from the previous videos, when we add fractions, we add up the numerators, which means it's 7 plus 7 plus 7 plus 7. So in the end, it's 4 times 7 over 20. 4 times 7 is 28 over 20. And now you notice, I've got more pieces than it was originally sliced up into, which means this must be more than 1, because it's greater than the number of pieces it was divided into. So when your numerator is greater than the denominator, we know that the value must be larger than 1. Okay, now how about multiplying fractions with itself? Or rather, multiplying fractions with fractions. Well, let me use an illustration to show you, to make a little bit of sense with this. If I have a cake and I divide it into 4 pieces, then one of the pieces can be represented with a fraction, and that fraction would be 1 of 4. This is how we can read a fraction, 1 of 4 pieces. Okay, now what if I multiply with a half? Now what happens when we multiply with a half? Well, think of anything else. If I say 5 times, sorry, not 5 times a half, 10 times a half, it means a half plus a half plus a half 10 times, okay? Or half of 10. Now half of 10 is 5, we know that. And 10 halves, if I add this for 10 times, I will also get 5. It doesn't matter which way you look at it. The point is, when I multiply with a half, I am halving whatever I'm multiplying. So if I look at a quarter and I multiply with a half, it means I'm halving my quarter. So instead of having a quarter, I must half that quarter. Okay, and now I'm only considering that portion. Now, how big is that portion? Well, if we half quarters, then the original thing was divided into 8. And I'm now looking at 1 over 1/8. I hope that makes sense. Okay, if I multiply with a third, sorry, not 13, a third, it means I am dividing something into 3 parts. So if I had a quarter, okay, so here's a new picture now so that we can don't get confused. Here's my whole, and I'm just considering a quarter. There's my quarter that I'm considering. If I multiply with a third, it means I'm taking a third of that quarter. So every quarter gets divided into 3. Okay. Equal sizes, again, not the same as my picture. Each quarter now gets divided into 3 parts, and now I'm only considering one of those 3 parts because I took my quarter and I divided it into 3, and I'm looking at one of those 3 parts. Now, it's 1 out of how many? 1 of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 1 of 12. I wonder if you can see what we're doing when we multiply with fractions. Well, it's quite simple. We multiply numerators with numerators and denominators with denominators. 1 times 1 is 1. 4 times 2 is 8. So that this is really very simple. If I were to multiply a half with, let's say, 4, we already saw, well, we only multiply the numerator, but that's because it's actually a half and multiplied by 4 ones. Okay, and then when I multiply numerator with numerator, denominator with denominator, I get 4 over 2. I'm allowed then to simplify, which means that any common factor gets cancelled. So 2 can divide into there once, and 2 divides into there twice, so that I have 2 over 1. And 2 ones is simply 2. Okay, or if I multiply a fraction, like let's say we have 3 over 4 times 4, okay, let's make it 5 over 6. Okay, now in this case, look what we can do. We say 3 times 5 over 4 times 6, 4 times 6. But this, I just want to show you something before we finish up, is that this 3 is a factor in the numerator, and the 6 here can be written as 2 times 3. In other words, there's also a 3 in the denominator. Okay, so that 3 and that 3 can cancel, so that my answer is in the end only 5 over 8. Now my point being is that when we multiply, before we actually go ahead and multiply, we can first cancel common factors. This all the factors of 3 may cancel with any one of these 2's denominators. Okay, so I can, in this case, I see 3 can divide into itself once, and into 6 it goes 2 times. So 1 times 5 would give me the 5, and 4 times 2 would give me 8, and I skip this whole middle step. Okay, let me do one more example like that, and I'll say, let's say we have 4x divided by 7y squared times 3y divided by 16 x squared. Okay, before we go and multiply numerator, denominator, and denominator, what we'll do is we'll first cancel this. 4 can divide into itself once, and into 16 it goes 4 times. 3 and 7, they can't cancel. 3 and 4 can't cancel. 1 and 7 obviously would stay the same. Now here's an x factor here as well, and there's 2 x factors here, so just one of them would cancel, so I'm left with 1 x factor, and there's a y factor here and a 2 y factors there, so again one of these will cancel and that one will cancel. Okay, so that now we can multiply what's left over. 1 times 3 is 3. There's no x's and y's left, but in the denominator we have 7 times 4, which is 28, and x times y are the remaining factors. And if you've done all of the cancelling here in the beginning, there should be no further simplification necessary in your final answer, but just always check yourself as well. You might have skipped one that could have cancelled. Okay, and then just finally, how about squaring numbers? How about if I squaring fractions? So how about if I've got something like 3 over 4 squared? Well, we know what square means. It just means multiply by itself. 3 over 4 times 3 over 4. That would give me numerator, 9 over denominator with denominator, 16. But notice, 9 is simply 3 squared. And 16 is simply 4 squared. So in the end, when I do have an exponent, so I've got a numerator over a denominator, and the numerator and denominator has an exponent, then what I'm allowed to do is give the exponent to the numerator and to give the exponent to the denominator. And that's what happened here. This became 3 squared over 4 squared in the end, and then you can simplify this direction if you needed to. That's me for now. I hope I've given you a few good ideas on how to multiply fractions with themselves, and that you actually understand how it's done. In the next couple of videos, we'll look at a few examples. I look forward to seeing you there. Cheers.